Roll.
Here we go. Thank you. Take it away.
So good afternoon, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those who don't know, we are all about bringing conservation, adventure, and science into classrooms around the world. Today, for at least the 20th time, we are joined live by the folks at the Schmidt Ocean Institute on board the research vessel Falcor, which took off in Punta Arenas in Costa Rica just 36 hours ago. Today, they're not going to talk so much about an expedition as some of their really neat robotics work. So they are working with autonomous vehicles to push the limits and test the boundaries of what we can do with these sort of vehicles as we seek to explore places like the bottom of the ocean or other planets in our solar system. So there's a lot of really interesting research there, and I'm going to turn it over to the team on board the Falcor to share a little more about what they're doing. Thanks so much for joining us, guys.
Hey, everyone. Hope you're having a great day at school today. I'm Zach. This is my friend Nick. We're going to do a quick introduction, and then we'll get into some questions that you guys have. So I'm from Beverly, Massachusetts, originally. I'm currently a first-year graduate student in the MIT Woods Hole Joint Program in Oceanography. And my home department in MIT is aerospace engineering. But as was mentioned earlier, we're working on an autonomous robotics mission here in Costa Rica. And we're really excited to hear the questions you guys have. And here's Nick.
Hey, everybody. I'm Nick. I'm from Colorado originally. So being out on this big blue ocean is a really new experience for me. But at MIT, I'm in my second year of my master's degree and also in aeronautics and astronautics. And Zach and I work in the same lab building out AI systems for spacecraft. So we get to test them out here on the ocean, but the goal is to be able to send them out into space. So I hope that you guys have lots of great questions.
Cool. Did you guys want to explain a little bit more detail about what you guys are doing, or dive right into questions, or how do you want to do this? It's entirely up to you guys.
Sure. Yeah, we can give you a little bit of an overview. So the Falcor is a really interesting ship because it has a high power computation system on board, which we're able to use to do things like mapping the seafloor or doing machine learning tactics to try and understand what the different types of undersea rocks or life forms are down there. And for our uses, we're able to use it to put an artificial intelligence system on the ship that helps us to decide where to go and how to get our vehicles into interesting locations so we can do good science. So we have a number of different vehicles that we can use to do that. One of them is the remotely operated vehicle, which you see on the screens behind us. This is a large vehicle that goes down on a tether from the Falcor itself, and you kind of drive it around like an RC car in a way. But it has some arms on it that you can use to pick things up from the seafloor, and a bunch of really good cameras on board, so we can take high-resolution pictures and then analyze them to see what kinds of life there is down there and what kind of geologic features there are, so the rocks and the landscape down there. You want to talk a little bit?
Yeah. So just a quick comment about why the autonomous platforms that we are providing are so useful. Well, the ocean's just really, really big, right? And there's interesting things down there, but we don't always know exactly where they are. So we might have like a general vicinity, like it might be within some range. And what's cool, what we can do is we can tell a robot like, hey, go look in this area. And then it will be able to think for itself, sense the environment, and then directly sample the things that we're looking for. So one thing in Costa Rica that's of interest to us is looking for carbon seeps coming out of the seafloor from hydrothermal vents. So yeah, the ability to think for itself and go ahead and go sample some interesting spaces for us is a really powerful tool.
Very cool. So gentlemen, before we got underway, Logan had mentioned to the few classes that were here before we started that one of the main benefits of this is this idea of lag time. So when we're dealing with robots on, say, Mars, there's many minutes that go by before our signals can reach all the way out there. So you guys are testing technologies that will enable the robots to, again, sort of make these decisions for themselves. Can you speak a little bit to that and how that might help, maybe especially in the space context?
Yeah, you hit on a really important point. when you have those kinds of communications delays, and this happens in the ocean as well, when we send the vehicles below, if they don't have a tether like the ROV does, then we can't talk to them because the radios that we use to talk to the robots, they can't penetrate through the water. So they need to be able to sense their environment and understand what their goals and objectives are and make appropriate decisions for themselves without having somebody babysitting them. So up until this point, we haven't had very good capabilities to do that. We basically tell the robots, go here, go here, go here, do this, and they follow a very rigid script. But what we're hoping is that we can tell the vehicles, you know, I'm really looking for something that looks like this, and I think it might be over here, and if you see something along these lines, then that might be interesting, so please go and find that for me. And if the situation changes, adapt. So when you're thinking about a space context, it's pretty much the same thing, right? You might have a 20-minute communications delay between you and the spacecraft, and it's just not possible to control it directly. So if you look at examples like the Curiosity rover that was landed a couple of years ago, it was doing this same kind of thing during their 7 minutes of terror landing sequence. And actually, the same techniques that we're using in the ocean right now are used for space context. So we are able to take these ideas and use them in a lot of different areas, which is one of the things that's really exciting about this kind of research.
Very cool, gentlemen. All right, I think that's a perfect primer to lead into our questions. I know we're already getting a whole bunch from Mrs. Spear, who's living up to her zillion question promise. So let's start, and I'll do introductions to the classes along the way. So Mr. Chin's class, grade 8 in Markham, Ontario, if you guys have a question to kick us off, go right ahead.
So our question was whether you guys have made any new discoveries and what kind of impacts have your research has made?
Yeah, so right now, what's kind of interesting is we're only in the first couple days of the cruise. And again, one of our main goals is to validate this new technology that we're providing. So what we've actually done is we've sampled some areas that have had we've had some knowledge about from previous cruises. So for example, there's this interesting formation on the seafloor called the Jacko Scar. And we had some knowledge of this beforehand. And it's basically from one tectonic plate subducting under another plate. And then it created this huge landslide feature on the seafloor. And what's interesting about that is that from previous experience, we knew that there was carbon presence from these hydrothermal vents. But what we did today, or in the past couple of days with the ship, is we go driving over that region, and we use the multi-beam sonar on the ship to then get an even better map of this area. So then once we have that, the map of the underlying sea floor, we can then send our robots down there to look for even more things.
Very cool. Did you say the name of that was the Jacko Scar?
Yeah, the Jacko Scar. The town that it's named after is in Jacko, Costa Rica, which is like the nearest town.
Okay. I just want to do a really quick follow-up as well. So you mentioned sonar in there and hydrothermal vents. So could you explain a little bit about what those are for classes that might not know specifically hydrothermal vents?
Yeah, so I'm not sure how well you guys can see these screens behind us, but this one up here is actually showing us what the multi-beam sonar is. And what the multi-beam sonar is we have this the sensor on the bottom of the ship that's sending an array, so a swath or a 2D slice of bathymetry below, and bathymetry is just the texture on the sea floor. So we get this array of measurements from sending a sound signal down to the sea floor, bounces back, we record the signal, and we know what distance it was. So we have the sonar measurement here, and then from those measurements, we can reconstruct the map of the underlying seafloor. So then as the ship is driving along, we can continually build and update our map of what the seafloor looks like below, and then that can help us make decisions later on. And then with the hydrothermal vents, so that's normally a result of magma being trapped under the sea floor somewhere, and then there's gases or liquids that are heated up by the magma, and then they end up coming through cracks or small volcanoes or vents in the sea floor, and they're usually very hot and they're bubbling. And the cool thing about those is that there's usually a very diverse life forms that live in that kind of environment. So it's usually a pretty interesting place in terms of biology, in terms of geology, and a lot of other features. So they're really cool to find.
Very cool, gentlemen. For the classes that are interested too, we've done several hangouts with deep sea researchers. Hydrothermal vents are amazing. I urge you all to look them up when you're done this hangout. Let's head to Ms. Hug's class. If you guys have a question, take it away.
We've been doing a debate in our classroom about how much money we spend on space travel.
And we were wondering how much money does it usually cost to build one of those robots?
Well, that's a very good question. So right now, to build one of these big ROVs like you see on the screens behind us costs a couple of $1 million. They're very large. They involve a lot of very expensive technology. And on what you get for your money is that you're able to do a lot with them. But on the other side, it means that only very well-funded groups can actually use these. So what we're testing is much lower cost vehicles where we want to be able to push that cost down to somewhere in the tens of thousands of dollars range. So that will open it up to smaller universities or maybe even high schools, if they get a grant, could be able to buy one of these vehicles and run it themselves. So with our computer science background, we're able to give more capability to those less costly platforms and keep them out for longer periods of time so that they can do more science. That said, there are very interesting robotics researcher projects that are occurring. One of the groups that we've worked with in the past is the University of Rhode Island, and they have a system that doesn't have any propellers or anything on it at all. It's called a photo float. So it's basically a canister that you throw into the water and has cameras on the bottom. And it can control how deep it goes, but it can't control anything else about where it moves. So it just gets drifted along by the currents and takes pictures of the seafloor. So that's actually surprisingly useful. And they're working on trying to figure out how you control it in a way that you can put it in specific locations, but that's also very low cost. And so there's a lot of very interesting work being done in trying to make sea exploration cheaper. So that same thing is happening in space. If you look at the systems that have been launched in the past, they tend to be very large because it's mostly been military and government contracts that have been able to put things into space. But the amount of interest in launching things has driven the price down, and now you can build very small satellites, which are called CubeSats, and they're no bigger than a shoebox. And you can launch them as a secondary payload, which means that they ride alongside a larger satellite that's being launched, and then they get spat out when it gets into orbit. And it makes it a lot easier to get new technologies into space.
Outstanding, guys.
There's been a lot of development there.
And I'm going to jump in real quick. My name's Logan. I'm with the Schmidt Ocean Institute. I'm not actually on the ship, but we are the organization that runs the ship. To get a little bit more specific to your debate, the amount of money that is spent on space versus spent on deep sea research, there's much more money spent on space right now. And part of that is because people are interested in that. And part of it's because as the presenters were just saying, the equipment needed is very expensive. Our foundation is a little bit different in that we are funded completely by our founders. So we do not take taxpayer money. We don't take money from anywhere else except for the people who founded the organization. But like the presenters are saying, a big deal of what we're doing is to try to share all of the information we discover. It doesn't really make sense to get information and then keep it to yourselves so that somebody else has to spend a lot of money to find the same information. So one of the things that's really happening a lot over the internet and over different types of social media and different sharings is to make sure that the information that's found gets to lots of other people so other folks can use it as well. And just a side note, when you were talking about different organizations that can work with students, there's one called Open ROV. And that is one that students, you guys can look at and get information about building your own underwater remotely operated vehicle. for very, very cheap. Because again, as the presenter was saying, a lot of the ways that we can do this is the more people that are interested, the less things cost. So we definitely encourage you guys to look into making and exploring with your own robotics. And now I'll hand it back over to the classrooms for more questions. Thanks.
Thanks, Logan. That was great. Worth noting, too, whenever cost is brought up, that out of the entire budgets of Canada and the US, it's like 3% of all the money goes towards science. So all the exploration, space, underwater, and otherwise, 3%, which is a very, very small amount. I forgot to mention, too, so Miss Hug's class is grade 6 in Guelph, Ontario. Sorry about that. Our next class is Miss Park's group, grade 6 through 8 in Fallon, in Nevada. So if you guys have a question, come on up.
Hi, I'm DJ, and I was wondering, is there going to be a faster way to communicate to spacecrafts or underwater vehicles?
That was a really good question. One of the things that makes it really hard is that we're actually limited by the speed of light. So that's a constant, and right now we don't know how to change it. If you figure out how to do that, that would be really great, and you should tell everybody so that we can all go faster than light. But when you're sending a radio signal out to a spacecraft, there's a certain speed that it goes at, and it can't go any faster. On the other hand, when we're talking to vehicles under the water, we mostly do it using sound. So there's a device called an acoustic modem, where it sends out sound waves that encode the data just like a radio signal would, except using sound instead of radio. And so there's other difficulties with that, but there's been a lot of development in that technology recently, and so we're hoping that we'll be able to use those to communicate with large numbers of these robots when they're under the water. We can't use radio, as I mentioned before, because it actually can't penetrate through the water. So we have to use something like sound.
That pesky speed of light always getting in the way of neat new science. Now, Miss Spears' class, you guys have written in, honestly, I think 15 questions, which, way to go, you proved your point. Do you want to actually just say one? I'm curious if you wanted to come up. So Miss Spears' class is in Holy Lake in BC, but feel free to come and say one to us.
Okay.
You're good? Oh, now you're demuted. Now you're good.
Hear you now.
What I was gonna say.
Okay. I guess one that is fascinating for us is the idea that there's living things down there, and they wondered if there are ever any problems because of the living things that are under the ocean. Like, do they get, caught by a squid, or do things crawl on them, and that kind of thing.
Yeah, it can happen. So when the vehicles are down underwater, they look kind of like the other living things down there. So, we've had instances where whales have come by and checked out our vehicles. We've had instances where like crabs will grab onto them, and it can cause problems because when you have a bunch of crabs on it, the vehicle can't move quite as well. Octopi will come by, and they're very curious. So they'll come in and check out the different vehicles and see, what is this thing? I've never seen this before. But for the most part, it's not a huge problem. It's actually kind of interesting when that happens. And we sometimes have problems not just from living things, but also from non-living things. We were on a similar cruise sponsored by the Schmidt Ocean Institute earlier this year in Hawaii, and we actually had an incident where one of our vehicles hit another vehicle and came back covered in a blue lubricant that they use. And so it kind of looked like we had hit an alien or something like that down there. There's no aliens under the ocean, but it kind of looked that way. So it's a teeming ecosystem down there, and things do happen. So
yeah, I actually have a funny story to add on to that. But yeah, I agree. Not usually a problem. One thing we do think about is we try to design our vehicles so that it has minimal impact on the life and the habitat of the animals. But I wanted to jump in with a funny story. One of our research advisors, Richard Camilli, was on a vehicle similar to Sebastian here that we see, the ROV. So he was physically inside Alvin, and Alvin has a robotic arm similar to Sebastian here that you see on the side. And what you can use the robotic arm for is to pick up rock samples down below near the sea floor and bring them back up to do whatever kind of sampling you're interested in. But as Rich was controlling the arm and picking up a rock, a giant squid came out of nowhere, grabs on to his arm, and then Rich was in this arm wrestling match with a giant squid, which ultimately Rich won, but he came away with a really awesome story from it. So.
That is awesome. For those who don't know too, Alvin is sort of the iconic research vessel in the entire world that people can go down in. So we did a hangout with the Woods Hole Oceanographic Institute recently where I talked and showed Alvin. So I'd urge you to check that out too. For the classes too, so like Miss Spears' class, they're passing along so many questions. Because the Schmidt Ocean Institute is all about this, you can send them in an email to Logan, who originally sent you guys the link today, and they'll answer all those questions later if we don't get to them all today. So please do that. So let's go now to Miss Baraja's class, so grade 6s in Oxnard, California.
Oh, they muted you.
Oh, they muted me finally. Thank you.
Oh, there we go.
Can you hear me?
Yeah, we're good.
Yeah.
All right. My question is, what resources are the robots made out of? Are they hard to find? Are they abundant? Or are they a mix of both?
Cool.
So a lot of the components that the robots we work with are actually carbon fiber. So abundant, not something we have to worry about as much. One of the resources within the vehicle that's a little harder to get your hands on sometimes is the components of the batteries. The lithium-ion batteries or lithium primary batteries are a little harder, but the carbon fiber, which makes up the outer hull or the outside shell, is pretty abundant.
And then one of the cool things that we've been using recently is 3D printing technologies. So we're able to build new components and design them on the ship to meet new mission needs that we have. So one of the examples is that one of our vehicles needed a new nose cone after an aforementioned contact incident. And so we were actually able to make a new one on the ship using a 3D printer. So that's opening up a whole new world of design and technology that before you had to design something and then wait several weeks before you actually got it back in the mail. But now you can design it and the next day you can have it in your hand and actually be testing it out in the water, which is very exciting.
Super cool, gentlemen. All right, we had Ms. Nunez's class, grade 6s in Benicia, California, also join us. So if you guys want to jump in and ask a question, you just need to demute your own mic. So a little microphone symbol at the top of your screen, and if you click that, you'll be good to go. I'll let you know when you're good, and you can ask away, and then we'll do a whole other round. So, yep, you're good, guys. Go right ahead.
My question was, how much money or how long did it take for to actually develop all of the technology? I'm a god.
And also, did you guys help design any of these, like robots or AI?
Yeah, so as far as the money goes, all of these things build on years and years and years of research. So to say that the specific thing has a particular price tag is kind of difficult because we actually build things with a lot of uses in mind. So the way that the research usually works is that an organization like the Schmidt Ocean Institute or corporate sponsors or government will give university researchers or even high school researchers grants and a specific amount of money to develop something that they think will have a positive impact. And so we're able to draw on all of that work that's been done in the open and to actually incorporate it into our systems. So Zach and I, we work on the AI system. So we tend to be more in the computer code rather than on the actual hardware systems. But we both have a background in making hardware as well. Add on to that? All right.
Awesome. Before we just go to another class again, I want to make a note that there's a few classes watching on YouTube Live. If you guys want to pass on questions in the chat bar, you can, and we will pass them on to Zach and Nick on the boat. I also, because Ms. Spears' class has passed along so many questions, I just want to pass along one from them, which is, how long has the program been running? And that's a question from that's a question from Lucas.
I'm not totally sure what you mean by program, but I will say that we've. Please go ahead.
Yeah, so the Falcor itself, how long has it been on the water? And then with this autonomous robotics research, has it been fairly recent? Or are you just starting now? What's the going on?
So the Falcor has been operating for quite a while. I'll leave that to one of the Schmidt Ocean Institute folks to clarify. But as far as the autonomous robotics exploration has been going, I believe that we've been working on it for about 4 years or so. So we've done cruises in Australia, in Hawaii, now in Costa Rica, and there's some upcoming ones occurring around the globe that we're hoping to push this technology even further. And so the goal is that as we do that, we can go into more and more challenging areas and test the robots in less than ideal circumstances and see how they cope.
Excellent.
Want to add on to that?
Yeah, and just a comment of the 4-year figure that Nick mentioned, that's for our group specifically, but there's other groups that have been doing different levels of autonomy for these types of robots for a while, probably, I don't know, 50 years at least.
Yeah, as long as there's been robots.
Yeah, as long as there's been robots. And again, it's all about building upon what we've done in the past. As Nick mentioned in the previous question, you never reinvent the wheel for any given robot. Usually it's a very iterative process where one robot will have one autonomy feature that is new and advancing the field overall, and then everyone else can utilize that and then build upon it further. So then you end up with this evolving system over time.
And just real quick, Falcor has been sailing for 6 years now.
Okay, excellent. Thank you, Logan. All right, let's head back to Mr. Chin's group. So grade 8s again, if you guys have a second question, come on up.
What challenges? What challenge?
Oh, what happened? Try that again.
Okay. What challenges did you guys face while operating the vehicles?
Yeah, so one thing, unfortunately, that we're dealing with now is some internet issues. So as you can imagine, we're out at sea right now, over 50 miles off the coast of Costa Rica. So we don't have the same access to, a cell phone connection or internet connection that you would have on land. And Nick and I, being part of a software team, a lot of our code we need to pull down from online to then run it on the ship. So one thing that's difficult for us is now that we have this limited internet connection, it's harder for us to build our software system in a quick manner. So then that slows us down a little bit.
Yeah, and so on the hardware side, one of the challenges is that the ocean has a very high pressure as you start going deeper down. So you need to make sure that everything is very well sealed and able to handle it. So when you're testing out these systems, what you'll generally do is try to make sure that you've got it as good as you think you can, and then put it down, say 100 meters, 200 meters, see if it holds, and keep on increasing the depth over time. And so sometimes things break, and you need to go and fix them. And being on the ship, not only are we limited in the amount of internet that we have, but we also are limited in the number of parts that we have on board. So we have some things like the 3D printer, which are fairly adaptable, but there's sometimes when you really need to make do with some bubble gum and some duct tape and maybe a nitrile glove or two. And we're trying to just keep the science going as long as we can with whatever techniques and workarounds we need to.
So given the choice between software problems or being attacked by a giant squid at the seafloor, would you choose the squid and hope for the best, or?
The squid is a way better story, so I might go for that one.
We just had a written-in question, which is, do you guys ever get seasick or homesick? How long are you guys on the journey? What does it feel like actually being on the vessel?
Yeah, I get seasick. That is that is a known fact. But when you're out here, it's so beautiful, and you're doing something that's so important that I think it's worth a little bit of discomfort. We are actually on the ship for 3 weeks. Which is not a very long amount of time, but it's enough that you start to miss home a little bit. There are other researchers that do long expeditions of multiple months, and they go into even worse conditions than we're in right now. So Costa Rica is just a lovely place to be, and we have no complaints at all. There's crews that go to the Antarctic or to the Arctic where they have to be bundled up all the time, or they may not actually be able to go out on deck. And so those are the real heroes actually doing the real hard work. So we're a little spoiled over here at the moment.
Yeah, and to jump on that, the weather, as Nick mentioned, we've had in Costa Rica has been tremendous, very calm sea. But another thing, when the ship is rocking quite a bit, it actually severely limits the science that we can do, because a lot of the vehicles are deployed by a crane. And if the ship is rocking too much, it's actually a danger to us and the vehicle to be deploying them. So there's a certain amount of roll of the ship. The captain will actually say, all right, we can't do operations right now. And then we're just kind of stuck on the ship without any science to do. So not only is it unpleasant and some people might get seasick, but it actually limits the science. So that's why we are always thankful for the nice calm days like we have today and ready to do some science.
Awesome. Well, let's head to Miss Huggs' class for a second question. Do you guys want to go ahead?
How long does it usually take to build the RVs and the technology?
How long to build a ROV or any vehicle?
Yeah.
Again, this kind of gets back where it's hard to put a specific number of time, a specific amount of time to a specific robot, because there's just so much work that's done beforehand that you build off of. And it's more like you make incremental changes to your system. And then it's a question of, oh, is this a completely new robot in itself? Or is it a new version of the robot, or so on? Do you have any specifics?
Yeah, so I'll just add that it really depends on how big the vehicle is and how deep it needs to go. So one of the things that you'll notice with the large ROVs is that they can go quite deep and they have a lot of capability. So they're very complex machines and they require a lot of engineering. That means that they'll take a number of years in order to actually develop and build. The smaller vehicles, you can build in 1 year or maybe even a number of months, depending on how capable it is. And that means that you can actually turn around new ideas much quicker, because you don't have to go through all of this engineering to make sure that it's not going to get crushed when you go down to depth and actually start to try and do your science. So there's a wide number of options for us, which is really good, because that lets us do a lot more interesting work and a lot faster and a lot cheaper.
Outstanding. I want to shuffle the queue a little bit here, just because there's been a student in Miss Baraja's class that's been waiting for like 10 minutes. So if you want to go ahead.
Can you hear me?
Yeah, you're good.
Yes.
So the thing you're trying to find, why are you trying to find it? What do you need it for?
So we're trying to find these hydrothermal vents, and one of the reasons why we're very interested in them is because most of the ocean is fairly chilly, right? It's actually kind of cold down there. But when you get these hydrothermal vents, because they're being heated by the hot magma that's underneath the Earth's crust, they're putting warm water that's very rich in nutrients onto the sea bottom, which supports a lot of different kinds of life that we don't see in other places. So that's very exciting. If we're able to go down and see new types of life, we might find something that we haven't actually ever seen before, which would be very cool. And then the other thing is that it also gives us a lot of insight about how the Earth itself works. So this area that we're in is very interesting because it has 3 plates that make up the Earth's crust that are all meeting each other in the same place. And when they do that, they interact in very interesting ways, where one goes down, one goes up, they slide and grind against each other. And so it gives us more knowledge about how the Earth's tectonic activity is working, so things like earthquakes and tremors, and just generally gives us more clues about how the Earth existed in the past and what life might have been like back then.
Excellent, gentlemen. All right, let's go to Miss Park's group. If you guys have a last question from your class, come on up.
How long are you out usually on a boat?
So these cruises generally last about 3 weeks, but that's mostly the ones that we've been on. So it varies from group to group. You might be out for a day, testing out a new piece of technology on a smaller boat. You might be out for multiple months on a larger one, or you might go to a remote expedition outpost to study someplace in detail for up to a year. So depending on what you're trying to look at, you might need more or less time. For us, 3 weeks is about ideal because we're able to go and do interesting science and test out all of our tools. But at the same time, it doesn't cost a whole lot of money. We don't need a lot of supplies, and we're able to do it much, much faster.
Outstanding. All right, so I want to take us for 2 last questions to Ms. Spear's group, because again, they prepared so many. So Ms. Spear, if you guys want to mute the mic and come on in, we can take them. I can also pass them on directly. I can just take the ones you've written. Up to you guys. Oh.
Hi, we have some very keen students. They're just coming. Some of them have stayed in and just to ask questions. So, okay, okay, ask.
Okay, you go
you
first.
Can hear you now.
You can go first.
Hi. Okay, what's your question for them, Hazel?
How much pressure does it take for the human body to get uncomfortable?
Like
how much pressure?
Yeah.
Ooh, so I guess from my personal experience, I can say even at the bottom of a swimming pool, I start to get uncomfortable. So that's only 10 feet or so. But the key there, again, if you know anything about diving, is that you need to equilibrate the pressure inside your head, because that's what's ultimately causing that pain. So if while you're scuba diving, you can actually blow on your ears, like you're popping your ears like you would in an airplane, and you can equalize that pressure in your head, and then you can actually go a fair amount deeper.
Quick follow-up. Sorry, go ahead, Nick.
Sorry, I was just going to mention one thing, which is that as divers go deeper and deeper into the ocean and the pressure increases on them, it actually also changes some of their the way that their body's gases are handled inside their bloodstream. And so when they come back up to the surface, they need to stop at regular intervals in order to let the gases dissolve back into their blood. Otherwise, you can get a condition that's known as the bends. So this is why it's important to get trained by professionals when you're learning how to scuba dive. And interestingly enough, this is one of the things that doesn't happen for people who are able to just hold their breath and go down underwater and come back up. So I'll pass it back to you.
That's very cool. I actually didn't know that about the people with breath. Quick follow-up, because when a lot of people ask about pressure, they want to know what happens if you took someone down to the low as you take the ROV and just put them in the water, what would happen to them?
That's an interesting question that I don't think that we could actually test, unfortunately. We have done interesting things by attaching styrofoam balls to the outsides of ROVs and sending them down, and you notice that when they come back, they're a lot smaller. So whatever would happen, it's not going to be pretty. The sea life that's adapted to living under the ocean at these deep depths is so able to handle the pressure that sometimes when you bring them back up to the surface as well, they don't handle it very well either. So it goes both ways. This is another interesting thing for space flight as well, which is that when you go under the ocean, you increase the pressure, but when you go into space, you decrease it. So the human body has a specific range that it's best adapted to living in. And understanding that is an important challenge for human exploration activities, whether you're going underneath the ocean or going into space, because you need to be able to keep people comfortable and able to work and not having problems with their ears. So.
Cool. All right, let's do one more with Ms. Spears' class, and then we'll wrap up right after that. So if you guys have one more question, because I know you stuck around just to ask, I'm skipping other classes, which we appreciate, so go right ahead.
Why would you want to learn more about space, yet we know little about the ocean?
Well, we want to know a lot about both. So we're actually here doing oceanographic research because it actually also helps us to learn both about the oceans, but also about space. The Earth is the only home that we have right now. It's the only one that we've ever known. So we need to know a lot more about it and to understand basically this spaceship that we're all living on. But on the other side, we also know that Earth is probably not unique. It's one of a number of different planets that we have in our own solar system, and there's so many other stars out there that have planets orbiting around them that we'd like to be able to know more about them so that we can understand more about ourselves. We fit into a broader cosmos that we can't be just focused on our own little existence down here, although that is very important. So I think that there's a lot of value to learning about both.
Gentlemen, before we wrap up, is there any last messages you'd like to share about your expedition, where classes can find out more information, any just notes you want to share with kids? Just take it away.
So Monica, who you probably heard her name in the beginning of the cast, is doing an amazing job in trying to put together all of our stories about what's going on the Falcor during our expedition. You can find these stories at the Schmidt Ocean Institute website, along with other expedition logs and videos interviewing the crews, and with video of the ROV dives when they go down underneath the ocean surface. Very cool to check out. I highly encourage you to look at it. And they also have a YouTube channel as well that you should take a look at. You want to add anything, Zach?
No, and you can also just track the Falcor whenever you want to, so you can see exactly where the ship is and get the updates of what science is going on at that moment.
And to piggyback, we also have Facebook and Twitter and Instagram, and all of those are at Schmidt Ocean. So I know some classrooms have been typing in questions that we haven't had a chance to answer now. You can send those to us over social media. You can go to our website, and like the presenter said, you can not only see what's going on live with the expedition, but you can send these questions directly to scientists or to other staff members at Schmidt Ocean Institute. So please do check out schmidtocean.org online, and then on any social media, it's at Schmidt Ocean, and we'll answer any questions that you guys have.
Super. All right, guys, what we do at the end of every Hangout is I'm going to demute the microphone of every single class. So boys and girls, if you guys could get ready and join me in saying a big thank you to everyone joining us today. So Mr. Chin, Miss Hug, Miss Spear, and Miss Barajas class.
Ready? Oh, thank you. Thank you.
Awesome, guys. Thank you so much for joining us. That was marvelous, and we look forward to having more with you guys very soon. And for all the classes, please do look up all those resources. Okay, guys? Have a nice day, everyone.
Thank you. That was a lot of fun for both of us.
Bye.
Thank you all, and remember, study math.